So good afternoon, sir. This is Johnny Insuncados. Today I will gonna present to you my own design in series DC generator. So in the diagram, this is the armature. So in the armature, we will calculate the generated EMF here, as well as the power generated in the armature. So also, in this part, we will gonna calculate the load voltage, or the VL, and the power delivered, or the PL. So in this case, since it is in series, so therefore IA is equal to ISE, or the series field current. Also the load current is equal. So IA is equal to ISE is equal to IL. So since it is in series form, um, so let's start in this diagram. So I give a the given parameters. So the number of poles is in the armature is 8 poles. Then the number of conductors, the total number of conductors is 500. And then the speed is 3100 rpm. Then the flux per pole is 12 milliweber. Then the number of armature current paths is 2, since it is in wave winding. So the formula is 2m. So simplex form, 1 is the multiplier, so that is put 1. So A is equal to 2. Then here is also I give um, the armature resistance, which is for this part. So and then the series field resistance is equal to 0.50 ohms. Also here in this part, the load resistance is 45 ohms. So let's start. First, the first thing we must do is to find the generated EMF and the armature in this part. So we already know how to calculate the generated EMF. We just simply use the Epson formula, which is P times N times Z times flux per pole over 60A. So we simply substitute all the values given. So after substituting or the values, so we get the generated EMF in the armature, which is equivalent to 1240 volts. So after we got the generated EMF, the next part is to find the IA here. So IA, since we don't know the current here in the diagram, so we must use the KVL. So upon applying KVL in the diagram, this is the equation. So E minus VB, or the brush drop, minus the IA times RA plus the so in this part, I since it is in series, so I get the R total, or the resistance total here. So that's why I put RA plus RSE, or the series field resistance, plus the load resistance. So that's why, since it is in series, so I simply we add all the resistance. So since the unknown is, we don't know the IA here, so we must find the IA. So IA is equal to E minus VB, or the brush drop, over RA plus RSE plus RL. So we simply put the values of the corresponding variable. So our generated EMF is 1240 minus the brush drop, which is 2 volts, then over our RA is equal to 4 ohms, then our RSE is equal to 0.50, plus the RL, which is 45 ohms. So we put 45 ohms. So upon using the calculator and solving this, we got uh, the IA, or the armature current, which is equivalent to 25 amperes. So we can say that IA is equal to IL is equal to IA. So since it is in series, connected in series, so that's why it is equivalent. The three are equivalent. So now we can simply get the power generated here in the armature. So this is the formula in finding the generated power generated on the armature. So PG is equal to E times IA. So since we already got the generated EMF, so 1240 times the armature current, which is 25. So the result of the power generated here in the armature is 31.012 kilowatts, or 31,012 watts. Since we already have the values of IL, and but we don't know yet the VL. So how to find the VL? Simply use the Ohm's law. So VIR. So IL is equal to IA. So therefore 25 ohms times RL. Our RL is 45. So 25 times 45 is equal to 1125 volts. Then so after we got the value of the our VL, or the load voltage, we go back to the proper formula and getting the power generated, or power delivered. So power delivered is equal to load current times terminal voltage, or load voltage. So 25 times 1,125. So upon calculating or multiplying these values, we get the 28.147 kilowatts, or 28,147 watts. So since we already have our power delivered, so we can also get the efficiency of this generator. So efficiency, the formula in getting the efficiency is equal to PL, or the power delivered, over power delivered plus power losses. So we all know that in this part there is a power losses here, as well as here in the resistance field. So na yun ay kuan siya losses dira dapita. So as well as here also in the brush drop, so we also a power losses here. So power losses is equal to IA squared times RA plus IA times VB plus IA squared times RSE, or the series field resistance. So upon adding all the power losses, we get the power losses of 2864 watts. So now we can solve the efficiency of the generator. So RPL is 28,147 watts over 28,147 watts plus 2,864 watts times, to make it a percentage, so we times it a 100%. So upon solving this, we get a 90% efficiency of this series DC generator. So that would be all, sir. Thank you.